something we call the three-box model, which it starts really page 260, 261 in there. And this overhead is not very good. You may want to look at 261. But basically, memory works like this. You have what's called your sensory register. That's where the information from the environment comes into your body and into your brain. Your sensory register. So, this is what you're seeing, what you're hearing, what you're smelling, and so forth. And it has a very large, we know it has a large capacity. For instance, there's a lot of information coming in through my eyes now, a whole room of information. But what am I going to remember? The sensory register can hold a lot, but it doesn't stay there for a long time. It has a very brief retention of images. My sensory register will hold what I see for about half a second. There's a good example of this is if you take a light. I don't know if this will work with my little light here. Take it here. If you take a light and swing it around, can't you see kind of like a trail of light? It's hard to do unless it's darker. You can, if you look at it, you can kind of see the light is here, but there's a little trail behind it. If it's dark, you can notice it a lot better. You've seen guys moving flashlights around. It seems like there's a little trail. That's your sensory register. That's you're holding the image of the light in your brain, and you have a memory of it, and it stays there for about a half a second for what you're seeing, and about 2 seconds for what you're hearing. So you can remember pretty much everything you hear for about 2 seconds, and then what's not important disappears. Very often I call on someone who tends to be sleeping, and I say, "What are you doing?" And they're able to repeat just the last few things that I said. But the sensory register, this information doesn't last very long. What happens is your brain takes what it thinks is important and stores it in the next box, which is called short-term memory. And this is what we were measuring yesterday when we did our little test. Short-term memory has a limited capacity, can store items for up to 30 seconds, involved in conscious processing of information. So you need to have something in your short-term memory, and then your brain determines if it needs to go into long-term memory. Getting it in long-term memory is a little bit more difficult. If it doesn't make it into long-term memory, it will be forgotten. So some of your sensory register you deem important, you put it in short-term memory, and you hang on to it for about 30 seconds. Kind of like a phone number somebody gives you. 2012Psy258-267. I gave you that phone number. 351-8652. 285-4735. You remember the second number? Remember the first number?
365 something 052.
Was the first number?
052. It was?
If you don't deem it too important, it won't stay in long-term memory. I know the first number I gave you, I made the other two up, was 265-7052. That's my buddy Bud Otten's phone number from when we were 7 years old. I have no idea where he is now. For some reason, I stored that in long-term memory. I used to call him a lot. Bud, what's up, buddy? Let's go ride bikes. I don't know what we did back then. Anyway, long-term memory can hang on to something forever. And, or years and years, not necessarily forever. You do forget some things. There should probably be an arrow going down here that says forgotten, because you do forget some things that were in your long-term memory. But some things can last your whole life, and you do remember things for your whole life. So, we think of memory as three boxes. Sensory register, short-term that holds it for a brief time, and if it's important enough, long-term. You will retrieve it from your long-term memory and put it back into conscious thought. And that's what this arrow means, retrieve. You can take stuff from your long-term memory and somehow, we don't know how it works yet, put it back into your conscious thought. Somehow it's stored away. We don't know how it's stored yet. These are things that they're going to figure out one day, how a memory is stored. And that will be one of the major discoveries in the history of science. We just don't know exactly how it works yet. It involves the little axons and synapses, and they're making progress on that. And there's some theories that are good up there. But you'll hear, probably in your lifetime, you'll hear about that. Hopefully in my lifetime. I'm interested. Let's see. I want to get to some memory tests. I'm skipping through some of these notes kind of quickly. There's some memory tricks that you can use to put things into memory. Have you ever heard of something called chunking? Chunking is storing a memory more easily by putting it into groups. And let me do an example of chunking right here. Let's do a little memory test. Get a sheet of paper out. All right, you ready? I'm going to read a series of letters. You try to memorize them as best you can. And when I say go, you try to write the letters I just read. Get as many of them right, hopefully in the order I read them.
You really want an order?
Yes, I really want the order.
Is this the same thing we did yesterday?
Similar to what we did yesterday, that's correct. All right, here we go. X, I, B, M, C, I, A, F, B, I, C, B, S, M, T, V, go.
Exact number I can remember this year.
Okay. Turn your paper over. That was a series of 16 letters, by the way, and most people don't have a short-term memory more than 7. So if you got all of those letters by memorizing them individually, you're some sort of superstar. I'll read you the answer in just a minute, but I'm going to read you again. Did you turn it over? I don't want you looking at the same list. I'm going to read you the same list of letters, but I'm going to let you utilize a process called chunking. Chunking is putting information together to make it meaningful. It's the same list of letters, okay? Listen closely. X, IBM, CIA, FBI, CBS, MTV. Go. Okay. Here's the answer. And you can grade the, let's grade the second one first. It was X, IBM, CIA, FBI, CBS, MTV. How many got the second list completely right?
What did you get the wrong?
I missed like one.
Okay, if you missed one, that's fine. Did you get a lot more than the first list?
Yeah.
No.
Turn over to your first list and see how many you got.
Infinitely more.
X, IBM, CIA, FBI, CBS, MTV.
I got the exact same number
I
for
don't
both.
think
Huh.
I'm stick figure showing.
You might have some sort of weird brain wiring.
Really smart.
You can't chunk.
Chunking is putting meaningful information together, and the second list of letters has 6 chunks of information, which is usually in most people's short-term memory capacity. So 6 chunks of information, even though it's the same information, if you chunk them together in something meaningful, IBM is meaningful to most people. That's the computer company. CIA, FBI, MTV. Those are meaningful 3-letter words, and so you can, oh, it's the FBI, the CIA, I got this. It's just a few chunks. Whereas when you read them letter by letter and you aren't able to put any meaning to it, it seems a lot more difficult. Let me show you another example of chunking. Memorize as many chess pieces as you can as you look at this.
Memorize your color.
Bam! If I gave you a chessboard, could you set that thing up?
Nope.
How many pieces do you think you'd get?
5, 4.
Most people wouldn't get more than 7. Say 7 plus or minus 2 is short-term memory. When you're memorizing individual pieces. But a chess player who really knows chess well does way better on this than a normal person. Why is that? Well, they recognize the setup of a lot of pieces. Like, for instance, they see this, and that's one chunk to them. Because that's what the situation is after you castle. And if you know how to play chess, you know the movement called a castle. And so that is one chunk to them. So they would see that and they go, okay, I know that. And then a real grandmaster would see this and go, oh, that's the Kornyakov position of the 1976 championship. Yeah, I know that very well. And so a grandmaster chess player, when they see this, can get almost the whole board right. Now it's interesting, there are some people out there called savants. And I'm going to show you a video of a guy who is just amazing. I'll show you a couple of videos before the end of the year. A couple guys who have brains, and that they'll see that whole board, and he'll be able to memorize every piece, to know every piece. Or usually they get like 98% of information right that comes into their brain. This guy, his name's Kim Peek. He can read a book. He holds it about this far from his face. He reads the left page with the left eye, the right page with the right eye. He can read it in about 10 seconds. Remembers 98% of what was on the page. Can't tie his shoes. Can't bathe himself. Very socially awkward. If you say, get a hold of yourself, man, he goes like this. Doesn't understand, you know. idioms or phrases that don't have exact meaning. Actually, he's not alive anymore. He just died 2 years ago. But he was considered to be the greatest savant that ever lived, because his memory was just unbelievable. But he remembers everything, and so somehow, it is possible to get all of this. Somehow that he as a savant is making the transfer from sensory register to short-term memory to long-term memory. Everything gets stored somehow. And this makes us think that your brain is probably capable of storing an unlimited amount of information. Because he can. And he was like a Google. Just ask him anything and he knew the answer, because if he had read it before.
Wait, does that mean the next day you can ask him to repeat what was on that page and you do it still?
Yeah. Did you ever see the movie Rain Man?
Yes.
I have it. You can rent it or take it home with you. Here it is. It's based on his character. It's a fictional story of a guy, but they based the character Rain Man, who's a savant, played by Dustin Hoffman, as Tom Cruise too, and it got Best Picture. It was wonderful. One of my top 10 movies ever. Anyway, the savant character is based on his character, and at one time a waitress comes up to him, and Tom Cruise is kind of asked her name, and she says, "Oh, it's Debbie so and so," and he goes, "Debbie, whatever, 251-3527," and she goes, "That's my phone number," and because he had read the phone book the night before of the city that they were in, and it was their first night in the city. And it was a true story based on Kim Peek. Kim Peek's dad had told him things that he had seen before, so that had really happened with Kim Peek before. Amazing. So Tom Cruise takes him to Vegas and he's counting cards and stuff. Tom Cruise is winning all this money. It's really a little bit harder to do Vegas than just memorizing cards. But anyway, some interesting things. Now, how does long-term memory work? Well, we think most people's long-term memory works like this. That you have what's called a conceptual grid in your long-term memory. You'll put something in your long-term memory like the word animal. And you make associations with animal. Oxygen, an animal breathes oxygen. So oxygen is in your long-term memory. You link oxygen with animal. Food is in your long-term memory. You link food with animal. Skin is in your long-term memory. You make a link.
Bless you.
So you tend to store things in your long-term memory by making links to words or ideas that are already there. Belvedere. Belvedere was my dog when I was a kid. Oh, he's so cute. He's white. He's real mean though. And you couldn't keep him locked up. He could dig under a fence, jump over a fence, pull a stake out of the ground. He would not be locked up, Belvedere. So, if I just said, memorize these words, Belvedere, blah, 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 and added some words there, you might easily forget Belvedere. But if you link Belvedere to dog and link it to me, you know who I am, you know what a dog is. Your conceptual grid would probably have a dog here somewhere and a link to Belvedere and a link going across to Mr. Willis over here. And so that might make you remember Belvedere. You might remember Belvedere the rest of your life because of the story I just told you. And I might see you in 20 years from now, and I might go, you remember the name of my dog? And you might go, Belvedere. Yeah, because it's stored in there. We think perhaps that these links are actually real, maybe connections, synapses somehow. Maybe somehow there's cells that know dog, and somehow there's a link to this new thing, Belvedere, that you've just learned, and somehow there's another link. Perhaps it's a neuron, a synapse, some sort of link in your brain. But we call this a conceptual grid. And so the easiest way to remember stuff is to make links. You can use this in learning stuff through the rest of your life. Okay? Try to make some link to it. When I'm teaching, I don't just say, memorize these. Pluto, Neptune, Miranda. These are names you need to know. I say, Pluto, that's the planet that's furthest. That's real cold on Pluto. So now when I'm giving you details about it, you're starting to make links, Ooh, Pluto is cold, okay? Pluto's way out there. It's a long ways away. We can't even see it. It's so far away. Even with our best telescopes, it's just a little pixel on a screen. Ooh, and you get an idea because you know what far away means. That's in your brain somewhere, and you know what cold is. That's in your brain somewhere. So you start making these links. The more links you have, the better you can hang on to the information.
How do you memorize the concept of a link? Like the word like has or is or can?
That's probably up there too, and that's part of its own conceptual grid. Like have means to possess, right? So you know what possess is own, to have. So you can probably throw verbs in there. Long-term memory comes in a couple different types. There are procedural memories, which is knowing how to do something. You know how to drive. You know how to ride a bike. You know how to kick a basketball. What? Didn't make much sense. You know how to kick a basketball.
I sure did.
Do it all the time when they call penalties on me. Fouls. What sport am I in? Knowing how to do something is a procedural memory. Knowing something is a declarative memory. So you can either know how to do something or know information. There's two types of information out there. Semantic memories are just general knowledge, like that you learn in school. About Pluto being the furthest planet out. That's a semantic memory. Episodic memories are personal recollections of things that have happened in your life. Oh yeah, I remember that time I kicked that basketball when that referee called that penalty on me. And so, that's it. Those are the types of memories. That's good multiple choice stuff there. Procedural, declarative, semantic, episodic. 4 choices. Multiple choice test. These fun?
Well, if the answer is episodic, can the answer also be a declarative?
It could be. So I'd have to word that question right. I'm good at wording questions. Actually, I steal them from the question bank that somebody else wrote. But I'm good at doing that. Let's do some more memory tests. Okay, you got your paper? I'm going to read the list. You cannot start until I say go. Try and list all the words that I say in the order that I say them, if you can. But if you can't, just list them all. Even if you can't get them in order, just list as many of the words as you can. And then we'll go back and grade you. You ready? Night. Hat. Train. Coat. Flood. Truck. Tornado. Noon. Car. Earthquake. Glove. Day. Fire. dawn, boat, shoe, go.
How many words did you say?
I'm not sure.
15, I think.
16. Let's grade it. You want to? Or as my uncle would say, you want to? Night, hat, train, just put a check if you get it, coat, flood, truck, tornado, noon, car, earthquake, glove, day, fire, dawn, boat, shoe. Count up how many you got. Don't lie or cheat. Never you do that.
Or tell them it is who.
It says in this teacher's manual, so it must be right. Most people get between 5 and 9 words. How many did y'all get?
11.
Ooh.
15.
15? Oh my goodness. Y'all are better than most people. How many got shoe right? Most people got shoe because it's at the end. How many got night right? Most people get night because it's the beginning. We call this the serial position effect. And if you do this activity with most people, they will get a lot more at the beginning, few that were in the middle, and a lot more that were at the end. Was that true in some ways with your list?
Indeed.
Trey, what about yours?
Only got one.
One? Which one was it? It was hat?
Yeah.
Huh. That was at the beginning. So it was true with you. Your graph would be like this. Woo! So we call it the primacy effect, the fact that you tend to get some at the beginning, and the recency effect, the fact that you get some at the end. This is the reason why studying works best if done in smaller time periods. For instance, those of you who come up to me, and I get it all the time, every test, I studied 10 hours for your test, and I still failed, Mr. Willis. It's usually something like that. Well, you really, if you go for a 10-hour period, you really remember maybe what you studied in the first hour pretty good, and what you studied in the last hour pretty good, and everything in the middle is pretty much forgotten. So you really only studied for a couple good hours, and the rest, although it probably did help some because this is not zero, it didn't help as much as it could. So the better way to do it is to study for an hour, and then take a long break, and then study for another hour, and then take a long break. The break, depending on what research you follow, should be at least an hour or two if you're going to remember the most stuff, but it can be less. Even 10 minutes is helpful. Think about this next time you're studying. kids tend to do better that read some every night instead of trying to cram it all in one long period. So that's kind of why we urge you to be consistent in your studies. Here we go. I got another list. You ready? I'm going to read another group of words. You do your best with this. Here we go. Pencils down. Bed. Silence. Snoring. Tired. Turn. Quilt. Fatigue. Night. 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 Dark. Clock. Toss. Artichoke. Rest. Dream. Go. All right, I'll read you the answers. Check how many you got. Bed, silence, snoring, tired, turn, quilt, fatigue, night, night, night. Night was 3 times. Dark, clock, toss, artichoke, rest, and dream. Count how many you got, Ron? There's some interesting things that it says in here, so I'm going to read them all to you. On average, students will recall about 10 items correctly, which is considerably better than the last list, because these words are all related except for one. Most people recall bed because this word is the first presented. In general, the first bit of information to enter the memory has an advantage because people rehearse the item more frequently. How many got bed?
That was one of the last ones I got.
Recency effect. Nearly everyone remembers dream because this word is presented last. In general, the most recent information is better recalled. How many got dream? Frequency. The word night enjoys a memory advantage because it's presented 3 times. The more we rehearse material, the more likely the material is to enter our memory. How many got night? Get it 3 times? Distinctiveness. Students generally have little trouble recalling artichoke because it is distinctly different from the other words, all of which involve sleep. How many got artichoke? Distinctiveness is important. Many students recall toss and turn consecutively. This illustrates that the mind imposes an organization on new material. It organizes small units, toss and turn, by chunking them into one unit, toss and turn. How many got toss and turn consecutively? Some. Reconstruction. Many people remember hearing sleep, although sleep is not included in the list of words. How many put sleep? Yeah. We tend to fill in gaps in our knowledge with words or ideas that ought to be there, according to our schemas. Memory is not a direct sensory readout of previous information, but in large part a reconstruction about what the past might have been like. Visual imagery. Many students try to remember the words by forming a visual image of a bedroom. They can use their mind's eye to look around the room, locating objects that were on the list. This is a very useful mnemonic device. How many formed an image of a bedroom in their head to help memorize the information? A couple? Good. So you're hearing the words, you're putting the things in the bedroom, and then you look around the bedroom to retrieve the information. Very interesting stuff. So, you are to read tonight through page 267. Could very well be a quiz on Monday. And that is that.
You just hit this.